Now we'll look at an example of subtraction of scalar multiples of two vectors. We're given vectors c and d in component form. We want to find negative 3 times vector c minus 2 times vector d. So we'll first perform the scalar multiplication, meaning we'll multiply the components of vector c by negative 3, then we'll multiply the components of vector d by positive 2, and then we'll find the difference by subtracting the x and y components of the two vectors. So we have negative 3 times vector c minus 2 times vector d. So we can write this as negative 3 times vector c in component form minus 2 times vector d in component form. And now we'll perform the scalar multiplication. So we'd have an x component of negative 3 times negative 2, that's positive 6, and a y component of negative 3 times negative 3, that's 9. Now we're going to keep this a subtraction problem, so we're performing scalar multiplication with a positive 2. So 2 times 3 is 6, and 2 times 2 is 4. Just like arithmetic, we could write the subtraction problem as an addition problem, which we'll take a look at in a moment. But now to find the difference, we'll subtract the x components and subtract the y components. So we would have 6 minus 6 and 9 minus 4. So the x component would be 0 and the y component would be 5 of negative 3 times vector c minus 2 times vector d. This would be our resultant vector. But I also want to show this on the coordinate plane. But before we do that, it'll be helpful to recognize that negative 3 times vector c minus 2 times vector d is equivalent to negative 3 times vector c plus negative 2 times vector d. So let's take a look at this on the coordinate plane. Looking at the graph of vector c graphed here in blue, negative 3 times vector c would be this vector here in the opposite direction, but 3 times as long, or having 3 times the magnitude. And given vector d here, negative 2 times vector d is the vector in the opposite direction with twice the length or twice the magnitude graphed here. And now that we know that negative 3 times vector c minus 2 times vector d is equivalent to negative 3 times vector c plus negative 2 times vector d, we want to find the sum of these two vectors. On the coordinate plane, there's two main ways to show this. One way would be to take the vector negative 2d and place the initial point at the terminal point of vector negative 3c, which would look like this. And the resultant vector would be this vector here with the initial point at the initial point of negative 3c and the terminal point at the terminal point of negative 2 times vector d. The second way to show the sum would be to form a parallelogram using the vector negative 3c and the vector negative 2d. Notice to form the parallelogram, we would copy vector negative 3c here, and the resultant vector would be the vector that's the diagonal of the parallelogram with the initial point at the origin. Again, we have the vector here with an x component of 0 and a y component of 5. I hope you found this helpful.